A carnival is full of things to play, watch, and win, but there's one part we did not want to ignore: the food stalls. They are busy, fast, and sometimes a little chaotic, just like a game. We were inspired by fast-paced cooking games where teamwork, timing, and small mistakes can change everything. So we asked, what if that food stall energy became a physical carnival game? From there, our idea became Cheeseburger Fries Rush, a two-player cooking challenge set inside a carnival-style food stall. But we did not want to make another screen-based cooking game. We want a player to use their whole body, not just tap a screen. They need to move, grab, pass, chop, shake, fry, and react. So the game becomes playful, physical, and cooperative. Work together, survive the chaos, and finish the order in time. To make the game clear, we organize it into three main parts. Player 1 is responsible for chopping and shaking, and Player 2 is responsible for frying and seasoning. The common area is where the order is assembled, weighed, checked, and complete. The audience area is the control center of the game, where the order, countdown, and chaos are managed. The receipt tells player what to make, and the iPad shows the time and progress. But the audience can also trigger chaos floor. When the button lights up, they can press it to turn a player's floor red. The player then has to jump out and hit the emergency button until the danger disappears. This turns the audience from viewers into part of the challenge. Around this structure, lights, sensors, sound, and danger clues create the pressure of a carnival cooking challenge.
The first big challenge was not the technology, it was the game flow. At the beginning, we imagined a larger and more spectacular setup. One idea was to add a train track-like system in the middle of the game area. It sounded fun, but it quickly made the game too large and too difficult to control. The early version had too many actions, too many objects, and too many things happening at once. Instead of playful chaos, it started to feel like confusing chaos. So we made an important decision: simplify the game. We removed the parts that were not essential to the core experience. Instead, we focused on 3 clear stations and 2 clear player roles. This made it easier for players to understand who does what and where things should go. The chaos was still there, but now it came from the time pressure and feedback, not from unclear rules. That became the foundation of the final game. The second big challenge was making the physical feedback reliable. We wanted the prototype to respond to what players were doing, not just sit there as static model. But once we connected multiple systems together, small problems started to appear everywhere. Sometimes the buzzer did not react. Sometimes the lights did not turn on after being connected with other parts. The FSR on the chalkboard was not always sensitive enough. The shakeboard connection could become loose during use. Even the weight scale was sensitive to very small changes. These problems made us realize that physical interaction is not just about adding components. The feedback has to be clear, stable, and understandable while people are actually playing. So we focused on the most important feedback moments. The receipt gives players a physical starting point. The weight scale and LCD make the final check visible. The LED, button, and iPad make the completion moment clearer. In the final prototype, each round begins with a new order. The receipt prints out, giving players a physical instruction they can hold and check. Player 1 starts by preparing the fresh ingredients. The shake action adds a playful physical movement to the preparation process. Meanwhile, Player 2 handles the cooked ingredients. Seasoning becomes part of Player 2's role. As ingredients move between stations, players need to communicate and coordinate. When the chaos cue appears, players need to react without losing track of the order. At the end, everything comes together in the common area. The final order is placed on the weight scale. The system checks whether the order is close enough to the target weight. If the result is accepted, the feedback shows that the order can be completed. This gives the players a clear ending point for the round.
After the main system could work, we focused on making it feel more like a real game object. We used 3D printing for parts such as the knife, pan, seasoning pieces, and the weighing area. We also used laser cutting for the chopping board and the ingredient box. The chopping board changed from a smaller first version to a large final version, so it became easier for players to use. Together, with painting, soldering, lights, butters, receipts, and physical actions, the prototype started to feel more like a playable cooking game. During the final exhibition, classmates and external players tried the game in pairs, with an audience role helping during some chaos moments. Overall, players understood the receipt and player 2's role quite quickly. However, player 1 needed clear cues for the chopping board and the ingredient box. For example, after chopping, players had to press for 3 seconds until the LEDs turned green. The ingredient box also needed players to keep pressing the FSR clip, so we sometimes had to guide them during play. Overall, the exhibition went well and many players enjoyed playing the game. Feedback included, "It's pretty fun," and "It was interesting but a little stressful." Some players also said the carnival theme felt energetic, and some parts needed stronger hints during play. For improvement, the wires could be fixed more securely, because there were many players and strong wind. We repaired the chaos floor once, and the skill sometimes made players wait longer for the final check. Through this project, we learned that physical interaction design is not only about making the technology work, it's also about making the rules, feedback, timing, and teamwork clear for players. This is Cheeseburger Fries Rush, where cooking becomes a game.